Hit next, run it on ESXi 6, choose whichever storage. And here I'll choose the compatibility 7.0 intentionally. I created dummy 76, okay. Let's say dummy 76 is powered on. For a moment, think about it that, this is running the VM, running, the current VMware tools. Okay, this is a dummy machine. It is not doing it. Of course, I understand. But think about it for a moment, it is. Okay. And now this is running on version, it is running on a lower version. Okay. And now you have to upgrade it to version 20. You will only do this when your VMware tools are up and running, right? So what you will do, you will come over here, you will come to compatibility and you will say schedule a compatibility. You will say yes. And then you will say which version you want to go with. So here I have got 20. So like you would have 20, 21 or something, you can do this. Okay. And then here you get the option only upgrade post normal guest OS. I mean, you have the option that when it should go for an upgrade. If it's an abrupt shutdown, then also go for an upgrade, or only upgrade it when I gently, power it off from the operating system. You have got both the options. I'll say, no, you don't have to do this. Simply go for an upgrade. Okay, and here I'll come and I would say power off. Yes. And you see it changes to 20 because I had the option over there. Okay. And now you can power on and basically you get to version 20. Any questions, Manjunath?
No, thanks.
Cool. So this is how you upgrade your environment, and this is how you basically go for all the 4 upgrade options. Now let me talk about the other thing that I wanted to talk about, which is basically memory reclamation techniques. What is a memory reclamation technique? Why do you need it? How does it help you? Let me answer all those questions. So we have been talking about throughout this course that ESXi gives memory to the virtual machine, right? But there is a time if the utilization is super duper high. Okay, if the utilization is super duper high, then basically ESXi will start asking for the memory back because ESXi also needs some memory. Okay, so that is the point where we say memory reclamation techniques. This basically means that the ESXi wants memory back. Who would give back the virtual, who will give back the memory? It's the virtual machines. Because ESXi gave virtual machines the memory. Now the utilization is very high on the ESXi. So ESXi will start reclaiming the RAM. And this is called memory reclamation techniques. How it works, what it is, let me talk about it. The first thing is,
Can you demonstrate this again there? Again, repeat what you said about here again. I didn't really get it. Thank
so
you.
ESXi keeps giving RAM to the virtual machines. Okay. If the RAM utilization on the ESXi is super duper high, then ESXi will basically start asking for the RAM back. It will ask the virtual machines to give the RAM back. This is called memory reclamation techniques. It is a process wherein ESXi starts asking for the RAM from the virtual machines because the RAM utilization on the ESXi is very high. Okay. How does it work? What the options are, what the techniques are, let me show that to you. The first thing that you need to keep in mind is basically there is a term called min-free. What is min-free? Why do we need it? Let me answer this question now. So the question is, when will ESXi ask for the memory back? Okay, when it was going to ask for the memory back. So that basically depends that what is the min-free memory over here. You see this? What is the min-free? So my ESXi has got 60 GB RAM. So here it is saying that if you do not have 1200 MB of RAM available, if you do not have 1225 MB of RAM available, then ESXi is basically going to ask the memory back from the virtual machines. Okay. What I have been telling you throughout this training, do not go above 80%. Okay. Whatever it is, CPU, memory, network, storage, on the ESXi, do not go beyond 80%. So if you have 60 GB RAM on your ESXi, I am saying do not use above 48 GB. This is what I'm saying. Memory reclamation techniques are saying that they will start working when you do not have 1230 MB RAM available. So you think about it, 12 GB RAM, VMware says that you should at least have, that's the 80% as per this ESXi. And this technique will basically begin if you have less than 2 GB RAM available. So this is something you would never see in your environment. So what I'm about to tell you, memory reclamation techniques, is all theory, but you would never see this in action. Why? Because you are going to maintain 80% of the utilization. You're not going to go above 80%. Then you have got DRS to take care of the utilization and all that. You will have, sufficient number of ESXi. So this is something that you're going to do. Okay. So this is why it is important that this is only a theory topic. You would never see this in action, but at least you should know that how the ESXi is going to ask for the memory back. Okay. So the first thing that you need to understand is about min-free. What is min-free? Min-free is the minimum amount of RAM that should be available on the ESXi. So what is that RAM for my ESXi? The RAM that I have for my ESXi is basically 1200 MB. This is what I have because my RAM is 60 GB. Depending on how much RAM that you have in your environment, you will have a different min-free number. Now the question is, how do you get to this number? There is a way you can calculate this number, that what is the min-free. Okay, let me basically explain it to you. So again, this is not required, but again, I'm telling you so that you have a good understanding on how it works. Okay, so for the first 4 GB of the RAM, so remember, every ESXi will have close to about 700 GB RAM, or it will have 1 terabyte of RAM, it will have 2 terabyte of RAM, or maybe 3 terabyte of RAM. Okay, you will have a lot of RAM on the virtual machine, on the ESXi. Okay, so the first 4 GB of RAM, that is from 0 to 4, the first 4 GB RAM that you have, there is a penalty of 6%. Okay, what is penalty of 6%? How do we calculate it? Let me show this to you. So let me open a calculator. So first 4 GB. So 4 GB into 1024, that gives you 4096. Okay. This is the RAM in MB. 6% of this. What is 6% into 6%? This is 245. Okay. So this is a standard calculation that you have. Okay. Now, for the next 8 GB RAM, that is from 4 to 12 GB RAM, there is a tax of 4%. Okay. So here you would have for next 8 GB. So that means 8 into 1024, which is 8192, into 4%. I'm sorry, 8192 into 4 percentage. It's 327. Okay. So let me write 327. Now, the next 16 GB RAM, which is from 12 to 28 GB RAM, there is a tax of 2%. This is something I'm telling you only for the interview purposes. Because if you give all these answers in details, the interviewer will, it will show you, to the interviewer that you have a very good understanding. Okay. So I'm talking about 16 GB RAM. 16 into 1024, okay, which is this number, into 2%, into 2%, which is again 327. Now we have calculated the RAM till 28 GB. After 28 GB, whatever is the available RAM on your ESXi, like I have 60 GB RAM, no? So 60 minus 28, I am left with 32 GB. 32 into 1024 into 1%. What is the remaining amount? Whatever it is, this is how you would calculate. Whatever is the remaining memory, you will calculate 1%, and that comes to 327 again. Okay. So after 28, whatever the remaining is, 1%. So for me, it comes to 327. Now I have to calculate all of this together. So I would say 327 plus 327 plus 327 plus 245. You see, 1226. And this is what I see over here as well. This is how you calculate min free. Okay. So it's very important that whenever you are explaining memory reclamation techniques in an interview, first explain how do you calculate this value. Okay. Now, depending on this value, okay, depending on this value, you have something called as a state. Okay. So if you have, oops, sorry. So here, what I'm trying to say is that if you have 300% of min free, the RAM which is stored by min free, if you have 300% available, then you are basically in the high state. This is what you see over here. So if you say high state, you means that you have 300% of this value available in terms of the free RAM, which is what the ESXi says, you should have. Okay. If you have only 100% available, let's say if you have only 100% available, then you are basically in the clear state. Then the state will change from high to clear. Okay. If you are in 64%, then you will basically change to soft state. If you are at 32%, you will change to hard state. And if you are only left with 16%, then you will basically go to low state. Okay. So looking at this, looking at the state, you can come to know that how much is the free memory available or what is the utilization. Generally and always you would see high state, but there are different states available as well. And this basically depends on how much percentage of minimum free is available. Always by default 300% is available, which is, that is why you will see high over here. Okay. Now the question is, if the memory is not available, you are saying that 300% should be available. If it's not available, then what is going to happen? Okay. The state will change. I understand if the memory utilization is low for the min memory. I mean, if there is not adequate minimum free memories available, the state will change. I agree. But what is going to happen in the background? Let me answer that question now. Okay. So basically, there are few ways via which ESXi reclaims the memory. Okay. The first way of reclaiming the memory is called TPS. TPS means transparent page sharing. What do you mean by that? That means, for example, you have an ESXi. On that ESXi, you created a lot of virtual machines, and they have the same operating system. Let's say everyone has Windows 10 on it. Okay. Now, you gave 4 GB RAM to every virtual machine. Okay. What is 4 GB RAM? If you talk about 4 GB RAM, a RAM of 4 GB will have memory pages in it. Okay. Every RAM, when you talk about, 4 GB or 5 GB, whatever it is, it has few memory pages in it. And memory pages have content, they have data. Okay. So what TPS is going to do is TPS is going to scan these pages, every page. This is page 1, page 2, page 3, page 4, page 5. So TPS as a functionality is going to scan all the pages that you have over here, and it will give a hash value. So for example, it will say that your hash value is A, your hash value of the page is B. Okay. This is for this virtual machine. Again, this is going to do the same thing for the other virtual machine as well. So you have 4 GB RAM, you have got memory pages, and I'm going to scan your memory pages and see that, what is the value that you have. Now, for example, let's say the contents of this memory page are exactly the same as the other memory, as the other virtual machine. Why? Because you're running an operating system process over there. Because if you're running the same operating system, Windows 10, Windows as an operating system also will require some memory, no? And it will be using the same memory pages. If you deploy Windows 10 once, or if you deploy it 100 times or 1,000 times, the basic architecture, the whatever the process is, that will remain the same. That's not going to be unique for every deployment, right? So when TPS finds out that you have a common page over here and you have a common page over here, it will basically delete this common page. And it will say that virtual machine, you should now access this page. Okay, so virtual machine is going to basically read this memories page. So here what it is doing is, it is removing duplicate pages. TPS removes duplicate pages. This is what it does on one ESXi. So TPS runs on every ESXi, right? So on that same ESXi, whichever the virtual machines you have, it is basically going to delete those duplicate pages, thereby saving the memory. This is what TPS basically does. Okay. TPS used to be enabled by default, say like 12 years back. Then VMware disabled it. Why? Because there is a bug in TPS. What is the bug in TPS? So what happened is, in a lab, an engineer was basically playing with TPS. Okay. And what he did was he created two virtual machines on an ESXi. Okay. He gave some amount of RAM, and he found out that from the virtual machine, he could access the memory pages which were not common. Okay. He found out that TPS had a bug, and that bug allowed the virtual machine to access the other virtual machine's non-common pages. So what TPS will basically do is, TPS will say, you know what, you both have got a common page. So you stop accessing this common page and you basically go over here and access this. This is what TPS is going to say. But this is only relevant for the common pages. What about the non-common pages? What about this unique page? So TPS had a bug wherein you could access the non-common page as well. This is what the engineer found out. This poses a security challenge, because of which VMware now has disabled TPS altogether. Okay. Now, earlier in 2003 and in Windows XP, the memory pages used to be 4 KB in size. Now with the newer operating systems, 2019, 2016, they have a memory page of 2 MB. Okay, they have a larger memory page. Why? Because it helps the application. So the problem is that when you have a 4 KB memory page, this is a small in size. The possibility of finding exact data in both the pages is high. Okay. However, if you have two big memory pages, okay, this is of 2 MB in size, this is of 2 MB in size, then finding common or exact data in this 2 MB page is very difficult, because this page is huge. Okay, this is a small page, so you could find, um, a lot of common pages. Okay, so nowadays finding common pages in TPS is very difficult because you have a lot of 2 MB memory pages. Okay, now, like I mentioned, TPS is disabled by default. Okay, so what will basically happen is, TPS earlier used to work between the virtual machines. So I'm talking about in 2012. Okay, in 2012, TPS used to work between the virtual machines, and it will basically find out that between the virtual machines, where do you have the common pages? Now, because of that bug, TPS has changed its basic, nature. So basically now, instead of looking at between the virtual machines, it basically looks only within a virtual machine. So only within a virtual machine, it will find out that are you having two memory common pages or not. If you have, then I will basically delete one common page. TPS now does not look into memory pages between the virtual machines. It only looks into the memory pages within one virtual machine because of the bug that I basically told you about. Okay. Earlier, RAM used to be high in cost. Earlier, the dollar value of the RAM was very high. Now, RAM is very cost effective. Okay. So you should not be worried about TPS. My suggestion will be do not worry about TPS because every ESXi now has 1 TB or maybe 2 TB of RAM. I've seen ESXis with even 3 TB of RAM. So don't worry about RAM. RAM is very affordable now. I'm only telling you these things because they do ask in interview. Okay. You don't have you will not be seeing it, but they still ask you in the interview, so you should know what TPS is basically doing. Okay. And what used to happen in the background and what happens now. So now by default, like I mentioned, because of the bug, TPS only scans the memory pages of a virtual machine within the virtual machine. So it is basically trying to see that, you virtual machine have got 32 GB RAM. Okay. So do you have any two common memory pages? If you do, I'm going to basically delete one. This is what it is doing only for within the virtual machine, not between the virtual machines. Okay. Now, the other thing is the other memory reclamation technique is basically called ballooning. Okay, before I come to ballooning, there's one more thing. Earlier in TPS, if you enabled it, okay, it would basically do the scanning between the virtual machines. Okay, you did not have granular control. Now you have a lot of granular control. That is, if you want the scanning of the pages should happen between the pink VMs only and not between the green VMs. Okay, so for example, you want that the TPS should work only for these green set of VMs, and it should only work for within the pink VMs. If you want to create groups within TPS, you want to have it between virtual machines, but you want to have, more control that, where you should basically look for the memory pages, not between all the virtual memories, not between all the virtual machines, only a set of virtual machines. If you want to do this, you can do this. This is basically called salting. The process of controlling TPS on how it scans the memory pages is called salting. Okay. So what you have to do, go to Google, and on Google, just type TPS salting. You will get the first article over here. Okay. And here they basically talk more about that how TPS salting exactly works. Okay. This is a chart that they have created. You see this salt value. So that basically we refer to as salting. So here basically depending on what value you are putting, okay, it will do a scanning between every VM on the ESXi, only some VMs, yes, among VMs, among, with the same salt, no TPS, no TPS. So depends on this graph, what you want to do. So here you have a lot of control now. Okay. You will have to basically read all these points as well to understand that, how this used to happen. But TPS salting is basically a method wherein you could control that how the scanning of the memory pages are going to happen. Earlier, you did not have this control. Now you have this control. Okay. The other method via which ESXi will basically get the memory back is called ballooning. Okay. TPS was the first method. The second method is basically called ballooning. What is ballooning? Now remember, ballooning only works if you have VMware tools. If you do not have VMware tools, ballooning is not going to work. Okay. The balloon driver is called memctl. This is called the balloon. This is the internal name for the balloon driver memctl. Now, what is ballooning doing? Let me answer this question. So if the ESXi is high on the utilization, ESXi will basically talk to VMware tools. So on a virtual machine, you install VMware tools, right? ESXi cannot look into the operating system. That's not possible, but ESXi can talk to VMware tools. Okay, remember, keep in mind that ESXi cannot look into the operating system, but it can talk to the VMware tools running in that operating system. So ESXi will tell the VMware tools that I need some memory back. Okay, it is going to tell the uh, VMware tools about it. VMware tools is going to fool the operating system. How? It is basically going to create a fake application. Now, if you open the task manager, you would see that every process requires a memory. Firefox, Google, whatever it is, they all require memory, no? So what would happen is VMware tools is going to fool the operating system in thinking that there is an application that requires memory. Okay. Operating system will give virtual RAM to this fake application. This virtual RAM information will be shared with the ESXi. ESXi is basically going to look for the physical RAM, which is mapped to this virtual RAM, and then it will basically pull that RAM back. This is what basically ballooning does. Okay. So in a nutshell, ESXi will reach out to the virtual machine VMware tools, and it will say, I want memory. VMware tools is going to fool the operating system in thinking that there is an application that needs RAM. Operating system will give virtual RAM. This virtual RAM information will be shared by the ESXi. ESXi will map this virtual RAM with the physical RAM, and then it will pull it back. This is how ballooning basically gets the memory back to the ESXi. Okay. After ballooning, you have something called as compression, the next technique. What is compression? Compression basically means that TPS, okay, like I mentioned, nowadays you have 2 MB memory pages, okay? So there will be a time wherein TPS will start breaking these 2 MB pages into 4 KB. This is what TPS will automatically start doing, okay? Compression basically compresses this 4 KB page to 2 KB. This is what basically compression does. Okay, so the 4 KB memory page will basically be compressed to 2 KB page. Okay, this is what basically compression is doing. Then you have an option called swapping. What is swapping? You remember when I was teaching you virtual machines, okay, and I showed you an option over here. That is, if you go to this location, okay, see this virtual machine has 8 GB RAM, right? On which data store it is running? This is running on SAN04, VM50. Okay. So you go to CD, VMFS, volumes, SAN04. Okay. Do an ls. Go to CD, VM50. Okay. Do an ls. Okay. Do as ls-lthra dot v swap. You see this file, 8 GB file? Why do we need it? Because it is required in swapping. Okay, what do you mean by swapping? When the ESXi is super duper high in terms of the RAM utilization, okay, then ESXi will basically take the memory pages of the virtual machine and start putting them on this file. Like the normal paging that happens, within the operating system, wherein the memory pages are moved to a hard drive because the memory utilization is high. Similarly, the same thing ESXi is doing over here for the virtual machines as well. Okay. So for the virtual machine, it is of 8 GB. It has 8 GB RAM. So ESXi will randomly pick the memory pages and will start moving them to this 8 GB file. This is why you need a swap file. Okay. And then this is what swapping does. So after TPS, ballooning, compression, the next thing is swapping, wherein ESXi will say, I have had enough. I will start picking your memory pages. I don't know which one it is because I cannot see your operating system, and I will start moving them to the swap file. This is why you need the swap file. Okay. Now, if the utilization is still high after swapping also, then ESXi comes into the last mode, which is called blocking. ESXi will say, I am not going to give RAM to any one of you. Any virtual machine that comes after me and says that, I want RAM, ESXi will say, sorry, I don't have RAM, I cannot give you RAM. This is what is basically going to happen. Okay. So what works at which state? Let me answer that question. So remember, I started off telling you what is min-free and how to do a calculation. We understood that for min-free, whatever the value is, if you have 300% of min-free available, your state will be high. Okay. If your state is high, over here, the TPS is going to work. The default TPS, that is, it is going to look for the common pages within a virtual machine. That is what it is going to do. If your min free is 100% available, then your state will basically change from high to clear. When it changes from high to clear, TPS will start breaking the memory pages into 4 KB. This is what it is going to do now. Okay, automatically this will start doing it. If only 64% of min free is available, then what would happen? Your state will change to soft. Okay. Over here, TPS will continue to work, plus ballooning will come into the play. Now, TPS and ballooning are working together to get ESXi memory back. Okay. If the utilization still goes high and you are left with 32% of the minimum free memory, now the state will change to hard. Okay. Over here, TPS plus compression plus swapping, they all start. Okay. If you are left with 16% of the minimum free RAM, then you state basically changes to low. Okay. Over here, all these three will continue to work plus blocking. ESXi will say, I'm not going to give RAM. This is what a memory reclamation technique is, and this is how it works. Any questions? Now, trust me, you're not going to see this in production. Okay. You would never see this in production, but I don't know, for some reason, interviewers are very crazy, asking all these things, how it happens on the ESXi. So you should know about it. This is all in theory. Okay. One more thing I want to tell you is, for example, right now, if you see this virtual machine over here, this has a swap file of 8 GB. Okay. Now, if I power off this virtual machine, edit the virtual machine, and give a reservation of 2 GB. Hit the OK button. Though we spoke about reservation that it should not be done, but I just want to show you because we're talking about swap file over here. Okay. Now you have 8 GB RAM. Out of 8 GB RAM, 2 GB memory is reserved for you. That means out of 8 GB, you will always get 2 GB RAM. Okay, this is what it means. Now, if I take you back to the command line and if I hit the up arrow key again, you see the swap file is of 6 GB now. Why 6 GB? Because swap file is always minus the reservation. That is what your swap file is. So the formula is your RAM minus the reservation that you have configured is your swap file. If you have an 8 GB RAM and if you have zero reservation, then your swap file is of 8 GB. If you have 8 GB RAM, you have given 2 GB reservation, your swap file is of 6 GB. Why? Because this 2 GB RAM, nobody can touch it, no? ESXi cannot give this 2 GB RAM to anyone. It cannot do a sharing of anyone. It cannot even take it back. So that is why it can only play with this 6 GB RAM. ESXi cannot even take the RAM back if it is high on the utilization. That is what basically reservation will do. That is why. So if the interviewer asks you that I have a virtual machine with 8 GB RAM, I powered it on, but I see the swap file is of only 4 GB, is of 5 GB, is of only 6 GB. Why? Because you have a reservation configured. Okay. These are few, interview stupid questions, they will ask. But this is something that you will learn with time. Okay. Yeah. So one last thing is I need to share your resume points. This is what you can mention in your resume. That if someone asks you that what you have been doing or how you have been managing your environment, okay, so you have to basically tweak your profile, okay, and mention all these things that I've been doing in my resume. So you can tell them that I install an ESXi, I decommission an ESXi, I build a virtual machine, I decommission a virtual machine. What is the process? What do you do? Now you have to make up these stories. Okay. You have to basically say that, to build an ESXi, we have a certified ISO, we follow a run book, and after the installation, we do this, we do that. We configure, p sort dumps, like I told you, we direct the log files. You have to basically tell them, what you have to do. Okay, how do you install a vCenter? What is the link mode? Have you done it? Um, what is the configuration? How do you take a backup? All these things that you have to talk about. Okay, then similarly for the virtual machines, ESXIs, all these options, whatever. We have done everything, in this training for all these options. So this is something that you will have to basically tell them. Now, before you start putting everything in your resume, you have to also basically go through and understand that, um, and make sure that this is something that you have done and just understand it once. Okay, this is important. So just make sure that you go ahead and do all these things so that you have an understanding. And then you can tell them that you can tweak your profile and you can say that this is what I've been doing. And this is how you can tell them. Okay, this is what it will be. So with that, that's a wrap of this course. There is nothing else to basically talk about. Any questions anyone has, you can let me know. If not, we are good to go.
I go for
Yes,
it.
good, good class, good training.
Thank
I'm
you.
happy I trained under you. So, my question is this: if we are to take start taking a certification on VMware, which one should we take first?
Not
Should we
right
have
now. Not right now. I would say first, for 6 months, only get experience. Work on the technology. Don't
Yeah,
go for
yeah,
the certification rush.
yeah. I'm not going for. I'm just saying. I'm not saying we are going for a certification route because we've not really perfected. I've not
VMware
really.
Certified Professional, DCV, Data
Okay,
Center Virtualization, VCP. That is what you need to go for.
okay. VCP. Okay, okay.
Yeah.
Yeah. Okay. Thank you. That's what I want to know. So
But
let the other
again,
person
my
ask the
suggestion will
question.
be,
Hmm.
get experience for at least 6 or 8 months, then only go for the certification.
Experience in terms of working or in terms of practicing what you've
Yes,
told us.
yes, working, getting the actual experience. When you get an actual production experience, then only go for it.
Hmm.
Because
Okay.
remember, certification is important, but not that important. Okay, you need to have the knowledge. If you have the knowledge, if you don't have the certification, that's okay.
Okay. Let the other person ask his question before we go further. Before I go further.
Yeah, Manjunath, you have a question?
Yeah, but, can you explain about license? You have time.
So, yeah, I can
Is there
definitely talk
any
about it.
type of license? There any?
Yeah, so you remember I was talking about licenses. I'll tell you again, no problem. So basically what you have to do, go to this URL, okay? VMware licenses William Lamb. You see, after Broadcom acquisition,
Yeah.
VMware has changed the way, it basically brings in the license. Okay. So this is their, you would say the premium pack. This is their VCF. Okay. This is the most expensive one. And here, all these options that you get, because remember, VMware has a lot of different tools. We have started only ESXi and vCenter, but they have so many other tools. You see this? Okay. So what we are basically saying over here is that with VCF, you get a lot of, different tools, that you can basically get. And then you've got these add-ons. Add-ons means you're paying extra. These are not included in VCF. Okay. If you want them, you can get it. If you don't want them, it's okay. This is what basically the first is VCF. Okay. After VCF, they have this another tool, another license, which is this one, Foundation Edge. Now here they have again, different set of, tools available, what you're going to get and what you're not going to get. So the point is with VMware now, after the acquisition, you have got limited number of licenses that you can go for. You see this, you have got VCF for the cloud service provider, you have got an Edge one, you've got an VCF one, you've got a VVF, okay? And you also have a VCF standard. So depending on what you need, you can get a license. Okay, depends on your organization's requirement. And remember, VMware has a lot of different tools. You have only studied one core component. After that, there are so many other tools as well. So when a company goes for the license, it basically, you are assuming that they are going to basically use all of these products. Okay. When you start studying all these products, then you will understand that NSX, HCX, DSM, they have a lot of value. Why do you need these tools? When you start working on it, then you will understand the value. But this is how the basically licensing works. Okay with you, Manjunath? You understand?
Yeah. Yeah.
Okay. Any other question, guys, if you have?
Yes,
So I know.
but go ahead.
Okay, if you format the ESXi host, so should we apply again license?
No, so you will have the same license. No, you can apply the same license. It's not going to make an impact.
Okay.
Okay, so you format the ESXi, that's okay, but you can apply the same license. If you change the versioning, so for example, when you go from 7 to 8, then you need to get a new license key. If you upgrade within the version, if you are like, going from 7.0 to 7, dot 3, then basically you're in within the 7 series, the same license will apply. When you change the series, then only you have to go for a new key.
So do we require the internet for that activate license?
No. It's only a 25 character key. You put the key in. If you don't have the internet connectivity, doesn't matter. It will go through. Okay. That
Okay.
is the best part with VMware licensing. You just have to put the key in and that's it. Any other query, Manjunath, if you have?
Yeah, I heard like license will be like a core based license. If, for example, if your ESXi host has some 40 core, so
Yeah,
you
it is a
purchase it.
core base now.
Yeah.
And
So
minimum you need to buy 16 core. I mean, it depends on, what sales is going to sell you because number of cores basically keep on changing, but it is a core based. Depending on how many cores you have, you will have to buy the license. So this, what I was showing you, VCF and VVF, these are all the additions. And depending on how many cores you have on your ESXi, you will have to buy number of licenses. The more cores, the more licenses. This is same for all the vendors. Every vendor has basically done a core-based licensing because you will only have two CPUs, but in one CPU you can have more than 100 cores now. I mean, that is the kind of processors you get in the market now. So everyone has shifted to core-based.
Yeah.
Any other query, Manjunath?
Yeah. As of now.
Cool. Yeah, Oni, go for it.
Yeah, bro. I'm appealing to you because this class is ended. There's no need. If I don't follow up with this class, I'm gonna lose everything. Although I have the video, so my lab is still what is my problem is. That's why
See,
I tried to
my
set up a physical lab. So if you're talking about
nah.
the other guy lab that you said if I have connected to, I have not. I didn't know about how to connect about it.
See,
Please.
my suggestion to you will be, Oni, it's very simple. You just need to follow the lab video.
I've
Okay?
watched
Follow
one,
the
two, three. Wait, I've watched the video to four. I'm on the fifth video now.
so
So
the
the way you
point
set up,
is,
the way you set up your
hmm,
open file, the creation, everything, I set up the same. I've shared my screen with you. Remember, you saw my storage. You saw all of them, Sun 01 to Sun 05. That's what I created.
hmm,
So I did all
hmm.
that. But now everything is gone. But they are still
Why?
there. If I open them up from the workstation, I see them sometimes. Sometimes I open them up, I don't see them. I'm telling you.
So what you need to do is, like you were doing last time, you were putting a lot of resources. And I told you to put less number of resources on your
I
ESXi, less
I did
number
all
of virtual machines.
I did that. Right now, how many? I have only two virtual machines in that
Hmm,
cluster. I have only
hmm,
two virtual machines that I created. When I try to create a third virtual machine, that's why it's telling me you can't create it. So when I try to check my storages, I can't see them.
hmm,
Then when I go even to the ESSI one, the way I have my first VM, I can't
hmm,
even see the VC, the VC VM, the vCenter
hmm,
VM, and the VM that I have, one VM that I have there. I can't see them.
hmm.
Then if I go to the storage is gone. All those storages that I attached there, they're not there anymore. I'm telling you.
Okay, okay. Let's do one thing. Okay. You reach out to Amit and take his lab and start doing the
Give me his
practice.
name. Let me know who's Omid. Give me his name so I can chat him up, so I can type it on the screen. Let me write it down because sometimes I don't really
The
get
guy
them.
who shares
Saying,
the Zoom URL.
okay, okay. I don't even
Okay.
know his name.
I mean, that's okay.
Okay,
I mean, if you don't know him, then that's fine.
so
Okay.
I
The
can,
guy who contacted you to join the training, the
yeah,
guy who shares the Zoom link, on the
I
group.
know him. Yeah.
Yeah. Reach out to him and tell him that you
Mhm,
want lab for the practice. He will give you the lab and follow
mhm,
my video exactly the way I have done it.
mhm.
If you run into issues, you let me know. I'll come on a call with you and I'll see your lab.
Okay. Let me ask you one more thing to get what you mean by asking for the lab. The
Hmm.
lab that you say he's gonna give me, is it gonna be a different VMware workstation I'm gonna be
No,
accessing, or
no. So what
I'm
would
gonna
happen is he will give
Mhm.
you a desktop. That desktop has a good i7 processor. It has a good SSD and it has good amount of RAM. Okay.
Okay.
And you just
Oh,
follow
mhm.
and
Okay.
you just follow the video like I have done
Mhm.
and
Mhm.
create the lab. If your
Mhm.
virtual machines are stuck, if
Mhm.
your storage disappears, you let me
Mhm.
know. I'll hop on a
Mhm.
call with you and I will
Mhm.
configure the entire lab with you.
Mhm. Thank you so much for that promise and everything. That's fine. One more
Okay.
question.
Hmm.
One more question. Last question. I
Hmm.
don't know why you don't want to answer that question.
Which
That's a
one?
question you can answer. Now I get a job, right? If I get a
Hmm.
job, I'm not gonna be working with this kind of lab that we are setting up, open
Right.
filer. No, I'm gonna work with a server.
Correct.
Like you said before in the class,
Hmm.
you're gonna have your storage somewhere else, some
Hmm.
in a different hardware. Then you're gonna
Hmm.
have your ESSI in a different hardware. That's what you
Hmm.
said.
Hmm.
Then you're gonna cover, let's say you have in your storage hardware, you have 2 terabyte there. You carve out
Hmm.
one 10 GB and attach
Hmm.
your ESSI, attach it to the
Hmm.
ESSI server. That's what you'll be
Hmm.
using, right?
Hmm.
Practically, this is what you told us theoretically. Now, practically, I just told you the same thing. But
Hmm.
I don't want to talk about let's leave the networking part of it out of
See,
this.
in production, what would happen is you will have a guy who takes care of storage. You will have a storage guy. In environments, you have a different guy who looks after networking. You have a different guy who looks after storage. There is a different storage team altogether. The storage that you will have in an enterprise that will be of capacity of 100 terabyte, 500 terabyte, 1 petabyte, or maybe 2 petabytes. There is a dedicated certified guy who will be managing the storage. You do